first of all, let's review real quick. When is domain not all real numbers, right? So what it is, usually it is domain is all real numbers. That's its default. Except for 3 cases, right? What's the first case? When you've got a variable under a square root.
In the denominator.
Good. If you've got a variable in the denominator.
And under square root in the denominator.
Good. The combination of the 2, variable in the denominator under square root. So for the variable under the square root, we say whatever is under the root has to be greater than or equal to 0. Otherwise, we're square rooting a negative number, which in this case, we're looking for real numbers, would not work. Then you've got where it's in the denominator. We just set the denominator not equal to 0, because if it was equal to 0, my equation would become undefined. And then the third is the combination of the 2 if it's in it's a variable under the square root in the denominator. And for those, we set what's under the root. Jeez Louise, struggling to write today. Root greater than 0, because it can no longer equal 0 because that variable is underneath in the denominator. So if it's not one of those cases, then we say it's all real numbers. But then obviously if it is one of those cases, then we have to pay attention to the individual case. So if you look at number 1, is there a variable in the denominator?
No.
Is there a variable under square root?
No.
Is there a variable in the denominator under square root? No. So this is all real numbers. Even though there's a fraction, the variable is not in the bottom of it, so it's fine. 2, we've got the variable in the denominator in a square root. So I'm going to set what's underneath that square root greater than 0, and I get x has to be greater than -7. So in words, this is all real numbers greater than so that x is greater than -7, okay? We're going to practice some interval notation because you're going to need it. So if I was to write this in interval notation, this would be a parentheses on the -7, and it would go to positive infinity. So we're going to practice this a little bit more on graphs. But just to review, if it's x is greater than -7, it means it gets a parentheses on -7, and it goes to positive infinity. Yep?
So you only use the x such that, and then
The wording on that was just like to match the WebAssign wording. If you're writing it out, no, if you're writing it out, you don't need, you could just write x has to be greater than -7, unless it said put it in interval notation, and that's when you would use that second part. You're welcome. So 3, I've got 2 things going on here, right? I've got a square root in the numerator, and I have a square root in the denominator. So the square root in the numerator has to be greater than or equal to 0, and the square root in the denominator has to be greater than 0. So I'm going to solve these separately. X plus 4 has to be greater than or equal to 0, so x has to be greater than or equal to -4. And my denominator, 2x plus 1, has to be greater than 0, so 2x has to be greater than -1, and x has to be greater than -1/2. Then both of these have to be true. It's an and statement, so I can only pick where this overlaps. -4, -1/2. The -4 is a greater than or equal to, which would be a bracket pointing to the right. And the -1/2 is a greater than, so it's a parentheses pointing to the right. And again, we only want where these overlap. The more specific restriction, which is x is greater than -1/2. So x has to be greater than -1/2, or in interval notation, -1/2 to positive infinity.
I didn't understand this examination. How do you know it's an and?
Because neither of those can be broken, right? If I take something like -3, let's say I take something like -3, right? It's okay in my numerator. This would be the square root of 1. That's okay. But if I put -3 in the bottom, I get -6 plus 1, and that's the square root of -5. It can't work. So whatever range I give has to work for both, which means it's an and statement.
So it'll always be an and.
For these, yeah. The only time it's not is when you have, like I'll show you in a minute, you'll have something that's a little different.
So how do you know to do like that, or to do the thing when you like plug in like the different numbers?
You can plug in, it's just extra work.
So you don't have to plug in the numbers?
No, just look at where it overlaps.
Okay.
Yeah.
So if there's a square root in the top and the bottom, it's an and statement?
Yep. Because they both have to be true. So x has to be greater than negative a half and greater than negative 4. The only place that overlaps is negative 1/2 to positive infinity. So I think, Sophia, you mean like when it was x squared with an inequality, that's when we test points.
That.
So if my initial question has an inequality in it, that's when we would test the points.
Okay.
This is just setting up the domain.
Wait, how did you get -3 from the x greater than?
I said if I plugged in negative 3.
Oh.
So that was an if. So ignore, I just plugged that in to test it to show you that it wouldn't work.
So was this a problem in our homework?
I don't think the numbers are the same, but there should have been one in the notes yesterday, right?
In the notes, but not.
I can't remember.
It wasn't.
'Cause
Yeah.
I don't remember doing any sort of graphing thing for the homework. I just kind of looked at the rules.
But it was in yesterday's notes.
Notes,
Yeah. If you see it again on a warm up, like ding 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 ding. Yeah. So now 4 takes it even a step further, sort of. Okay, I've got a square root in the top, right? So the square root has to be greater than or equal to 0. But this time it's not a square root in the bottom, but I do have a variable in the bottom, right? So this cannot equal 0. So for my numerator, I'd get x has to be greater than or equal to negative 7. And my denominator, x cannot equal positive or negative 2. If I had factored it, it would have been plus 2 minus 2. Solved it, I would have got negative 2, positive 2. Or use that even root property, add it, square root it, but put the plus and minus. Either way, you get that it can't equal those two. So now think about what this graph looks like. If I use the top, negative 7, it has to be greater than or equal to, it's shading everything to the right. But it cannot be negative 2 or positive 2. So that's open dots. It can't include those points, which means it starts and stops my range. So if I'm to write this in interval notation, it would be from negative 7 to negative 2, not including negative 2, so it gets a parentheses. Then from negative 2 to positive 2, again, not including positive 2. Hang on just a second, Audrey. Then from positive 2 to positive infinity. So it complicates it because it starts and stops your range. Yep.
You lost me after you figured out that it's x is greater than or equal to negative 7 and that x is not equal to positive 7.
So I graphed this part, right? I said greater than or equal to negative 7 would be a bracket, and it would be shaded to the right. If that was my only restriction, I would have just gotten that x has to be greater than or equal to negative 7. But the fact that I have that it can't equal positive and negative 2 means that there's holes on the graph at those points, which means it can't include those points. So it's all the numbers from negative 7 up to the first hole, which is negative 2. Then all the numbers in between, negative 2 to positive 2, and then a hole at 2, and then everything bigger than 2. So these parts cannot be included in my answers because if I use negative 2 or positive 2, my denominator is undefined, or 0, which makes it undefined.
So then I'm confused in the example we did yesterday. Why did you plug in the numbers and why aren't you doing that here?
You want to tell me which one you're talking about?
The last one that did this.
So we're going to be reading domain and range from a graph. When I'm looking at a graph, the domain is your x values, so it's all the values from left to right. When we're looking at the range, it's all the y values, which is the values from bottom to top. So domain x, range y, okay? And the answer is given in interval notation. Solid dots mean brackets, open dots mean parentheses, arrows mean negative infinities and positive infinities. So if my arrow is pointing left, it would be negative infinity, or down, negative infinity. If it's pointing up or right, it's positive infinity. We're also going to read something called increasing, decreasing, constant behavior from a graph. So when you're reading the graph, again, you're going from left to right. So all of these, we're looking at it from left to right, okay? Which means the smaller value is always going to come first in my interval notation. As I'm looking from left to right, I'm looking to see if it increases. So if my line is rising as I move from left to right, that's called increasing. If it's falling from left to right, then it's decreasing, just like positive slope, negative slope. And if it's flat or horizontal, that's not very flat, but you get the point. If it is horizontal, then it's called constant. It's not increasing or decreasing. Our answers are also given in interval notation this way. It is always an open dot, which means a parentheses, except if my graph starts or stops constant, which I will show you what that looks like because I think that's the hardest to wrap your brain around. So when in doubt on increasing and decreasing, put a parentheses. It is very rare that it is as a bracket because a single point cannot be both increasing and decreasing. So we put parentheses. It would start, which I'll show you, I have an example. It'll start or stop constant. So it starts flat with a solid dot on the left, that would get a bracket, or it ends on the right, solid dot, and it's like constant, that would get a bracket. Everything else gets parentheses. All right, so this says, find the domain, the range, and the increasing, decreasing constant behavior. So I'm going to start with my domain. Remember, my domain goes left to right. So let's look at this first graph. What's the smallest x that's on that graph?
-3.
-3. Is that an open dot or a solid dot?
Open.
Which means, what's it get? A bracket or a parentheses?
Parentheses.
A parentheses. So -3 with a parentheses. Then where do my x values stop?
2.
It stops actually here, right? There's a break in my graph. If my graph stops and starts, so does my domain. So it's going to go to where x is 0. But this time, that's a solid dot, so it gets a bracket. Then my graph starts again here, where the x is 2, open dot, so it's 2. And when does it stop? It doesn't, which means this ends with positive infinity.
Wait, so where does it break on the first one?
So it stops, like go from left to right, right? My graph starts here. I have points here, points here, points here. It stops here, and then it starts again here. So you're going left to right for domain.
I was looking at it like with 2 because it was going
Nope,
up
always, so domain is always left to right.
there.
Okay, now we're going to go range, which is bottom to top. So what's the lowest y value?
0.
0 and open dot, close dot,
Open.
open, so parentheses. Where does it stop next?
2.
2, open dot, close dot,
Close.
close to bracket. Then there's a break again, right? So it starts again at
3.
3, open dot, so parentheses, and it stops.
Infinity.
Good, it doesn't, so I go to positive infinity.
I don't understand what
So now I'm going lowest to highest, right? So this is the lowest point on my y-axis, and that's 0 for y. But it's an open dot, so it gets a parentheses. Then I have y values going all the way up to this point, and then it stops. So it's 2, solid dot, because it gets a bracket. Then there's nothing in between here. So my range stops. But then it picks up again here, which this value would be 3.
So it's not like where the dot is. It's like.
It's the y value on the dot. So domain was the x values. The range is the y values. Does that make sense? Okay. All right, now we're going to do increasing. Any questions from home? Everybody okay so far? Okay, now we're going to do increasing. Okay, decreasing and constant. So again, I'm reading my graph, and this is important, from left to right. So as I come from the left in this direction, the first piece of the graph I have is this little band, right? That little segment. Is that increasing or decreasing? It's increasing. So when we write the interval notation, we give the x values because we're going left to right. So it's increasing from -3 to 0, and then it stops increasing. Both of those get parentheses. Because remember, the only time a bracket happens on increasing and decreasing is if it stops constant or starts constant. Neither of those have happened.
So for the increasing and decreasing,
X. Yep, because we're going from left to right. The only time you use the Y is the range. Yep. Okay, then it stops and continues again. What kind of motion is this? Increasing, decreasing, or constant? It's increasing again. So then it increases from, my X value there is 2, and it continues to increase with my arrow to positive infinity. On this graph, at no point does it decrease, and at no point is it constant. All right, let's look at B, or number 2, okay? My domain from left to right.
-2 with the parentheses.
Good. Yep, so the arrow's this way this time, which means my x is going to keep getting smaller. So I'd start at negative infinity, go to -2, parentheses, because it's an open dot. And then start again here at 1, stop at 2, but the 1 gets the bracket, and the 2 gets the parentheses. Let me just change that completely. Range. Now I'm going bottom to top. What's the lowest y? Negative infinity. Then the first stop happens here, where my y is 0. It's an open dot, so it's a parentheses. Then it starts up again here, where my y would be 1. Stops here, where my y would be 2. The 1 gets the bracket. The 2 gets the parentheses. Now increasing, decreasing, and constant. So this first little arc, would we say that's increasing, decreasing, or constant? Careful. I go from left to right, so it's actually increasing. Do you see that? So is the arrow pointing down? Yes, but the arrow is pointing down on this side. As I move from left to right, these values are getting higher. Does that make sense?
So it's not from where it starts to where it stops.
It's from left to right. So this is, that little part is increasing from negative infinity up to, again, it's the x value, -2. And then it's also increasing here, again, from 1 to 2. And again, none and none. So if it was falling this way, that's when you would see decreasing, right? As you're going from left to right. All right, 3, domain, again, x values. So I'm going to start at, this would keep going left here. So negative infinity to, this is a -3, to -3 with a parentheses on the -3 because it's an open dot. Then it stops and starts again at -2 with a bracket on -2 because it's a solid dot. Stops at +1 with a parentheses because it's an open dot. Starts again at 3. Stops at positive infinity because that arrow is going to keep pointing to the right. Now range gets tricky this time, okay? Because if I start, let me erase this. My lowest y, I actually have a couple different places, right? Those y values are all 1. Some of them are open dots, but some of them are solid dots. If I have any solid dots whatsoever, it gets a bracket because it does include those points. So it's 1. And then I actually have y values going all the way up to positive infinity. These y values over here would have stopped, but because I have this little part covered over here, it's actually to positive infinity.
Wait, it's positive infinity because they're both arrows, right?
Yep, they're both pointing up. And even if you only had the one, if you only had the one on the right, if I didn't have this one here, and I only had the one on the right, I'd be going from these values all the way up. That would be, again, from 1 to positive infinity.
And what if one of them stopped and the other one?
So it does, right? The one on the left does stop. If I only had these two, then my range would be at 1, and then it would stop. So it would get a bracket on 1, then it would stop, and it would start again at 2 with a parentheses to positive infinity.
What if one of those two things, arrows, weren't?
As long as one of them points up, it's part of the range.
Okay.
Yep, so if you're saying like if this was a solid dot here, yep, it still would be to positive infinity because there are points going above. Not all the graphs have to have points going on, just some part of it.
Why is there one?
Because the lowest y is here, right?
Okay.
Which is 1.
But if they're not like connected, why is it good?
Because there's a y value for every part of my graph starting at 1 and going to positive infinity. If I moved up to like 1.2, right, there's a point here for that. If I and then I just keep going up to positive infinity. So as long as this one started the same level as this and goes up, it's going to positive infinity. If this was here, now there'd be a break in between. Now you'd get 1 and then stop, and then from 2 to positive infinity. All right, now let's look at increasing, decreasing, constant. Okay, this part of my graph is doing what? The blue part. Decreasing. So my x that starts it is the negative infinity. The x that stops it is negative 3 with a parentheses. This part here is what? Constant. So decreasing. And that part, because it starts constant with a solid dot, that's where my bracket comes. It's the only time that you get the bracket is if my constant line starts or stops with that solid dot. So this would be a bracket negative 2 to 1, but the 1 gets a parentheses because it's an open dot.
Is that for constant or decreasing?
Yep, that was constant. Thank you. That's constant. Negative 2 to 1. And then this last part is doing what? Increasing. And I wrote this one in increasing and it should be decreasing. Hang on. Increasing from 3 to positive infinity. Questions on those? We've got a couple more to work through, but I just want to make sure we're good before we move on. Okay. All right, so examples continued, find the domain, the range, increasing, decreasing, and then we're going to evaluate the function at the indicated value. So if you look at number 4, the first thing we're going to do here is the domain. So domain's going to go left to right here. The furthest point left is this one, negative 2. It's an open dot, so it's going to be a parentheses. Then it stops here. There's a break, so that's at 0 with a bracket because it's a solid dot. Starts here again where x would be 1, open dot, and then the arrow says it's going to continue to get bigger to infinity, so I go to infinity. My range goes from bottom to top. So the lowest y is here at negative 4. It's a bracket because it's a solid dot. And then there are actually values going all the way up with that arrow, which means it would increase to positive infinity. If I look at my increasing, decreasing, and constant behavior, the first part of the graph is falling as I move from left to right, so it's decreasing. I use the x values, which would be negative 2 to 0. Then my graph rises, which is increasing, and the x values again would be 1 to positive infinity. There's no horizontal parts, so there's no constants. The second part of this says f of 0. So what's inside the parentheses is the x value. I'm basically saying, what's my y if my x is 0? So x is 0 here, and the coordinate point for the y that matches that is negative 4. Go to the next question. F of 3, my x for 3 is here. There's a coordinate point right there, which is 0. So I want to give the y coordinate that matches that. Looking at number 5, my domain arrows point left and right, which means my domain is negative infinity with positive infinity. My range, the lowest y is here, which is 1. It's a solid dot. And then both my arrows point up, so it's to positive infinity. Increasing, decreasing, constant. From left to right, this first part is decreasing, so it's decreasing from negative infinity to the x value where it changes direction, which is 0. And then it goes up. So it's increasing from 0 to positive infinity. Again, no constant parts because there's no horizontal lines. And f of 0 means my x is 0. Here's the coordinate point. The y there is 1. Number 6, domain goes from furthest x, which is here at negative 5, parentheses because it's an open dot, stops here, negative 3, solid dot, so bracket. There's a break from here to here, then it starts again here at negative 1, stops here, positive 1 with a bracket. And then it starts again here at 3 points to the, this would continue go bigger, bigger, so it points to the right or positive infinity. Range is now from bottom to top. So because this arrow is pointing down, it means that my range would start at negative infinity. It goes all the way up to here. It stops horizontally but not vertically because these points pick up over here. The stopping point vertically would be at 3 and it's an open dot, so it's a parentheses. Then increasing, decreasing behavior. If I go from left to right, this first part's decreasing from negative 5 to negative 3. Points can increase or decrease, so they get the parentheses. Then it comes up, so it's increasing from negative 1 to 1. And then it's decreasing again from 3 to positive infinity. And again, no constant because there's no horizontal. F of negative 3 is here. Coordinate points there where the y is 1. And f of 1 is here. Coordinate points here where the y is also 1. Okay, even and odd functions are next.
One more thing, can you just tell me?
All right, even odd functions. So even functions are functions that are symmetric to the y-axis. It means I literally can take my graph and fold it along the y-axis like a hot dog and my graph would overlap. The way we test it in an equation is we replace x with negative x and see if it would simplify back to positive. So things like a square, if I plugged a negative x and then I squared it, it's going to go back to positive x. Things like absolute value, if I plug in a negative x, it's going to go back to positive x. Those are going to be even functions. Odd says take that same process, plug in a negative x, but when I do that, all my terms become the opposite that they were before. If that's the case, it's odd and it's symmetric to the origin. Symmetric to the origin means I can fold my graph down and over and it would overlap. The last one is x-axis symmetry. And it's when y is raised to an even power or an absolute value. And this means you fold it top to bottom and it overlaps. By definition, a function cannot have x-axis symmetry because a function with something that is raised to an even power, a y raised to the even power, or a y in absolute value, would fail my vertical line test. So the questions are going to say, is the function even, odd, or neither? Or test for symmetry, which is x-axis, y-axis, and origin. Okay, so to see if it's even and odd, what we're going to do is plug in for a negative x. If it's even, it's going to go back to the original equation. If it's odd, everything will change. And if it's neither, then it's neither. So if I look at 7, I would plug negative x in. Negative x to the third is negative x minus a negative x becomes, to the third, plus x. These signs do not match, but each of them are the opposite from where they started, which means this is odd. Do the same thing with 8. Plug in a negative x. Negative x squared is x squared. Goes back to the original, which means this is even. 5 minus 3 to the negative x becomes 5 plus 3x. It's not the same. The 5 is the same sign, but the x, 3x is different, which means this is neither. They either all go back or they all change. All right, this says determine if the function is even, odd, or neither, then determine if it has symmetry. So same start, negative x minus 1. This goes back to the original, x to the fourth, minus, this becomes positive x squared, but the negative's still there, minus 1, and it matches the original, which means this is even. I'll go back to the symmetry part after. This one, 2 negative x to the third plus 3 negative x, and I get 2 times negative x to the third, or negative 2x to the third, minus 3x. It doesn't equal the beginning, but it is the exact opposite, so it's odd. So remember symmetry, if it's even, it has y-axis, and if it's odd, it has origin. And a function, because these are f of x's, can't be symmetric to the x-axis. So this would be even and symmetric to the y-axis, and this would be odd and symmetric to the origin. Okay, zeros of a function. To find these, we just set our function equal to 0 and solve. So the good news is we have done this before. Find the zeros of the function. So f of x equals 2x to the second minus 3x plus 1. I change f of x to be 0, so I get 0 equals 2x squared minus 3x plus 1. And then let's see if we can factor it. 2 times 1 is 2. Factors of 2 that sum to negative 3, negative 1, negative 2. Replace your middle term with those. Factor by grouping. Take out an x. 2x minus 1, take out a negative 1, 2x minus 1, 2x minus 1, and x minus 1. Set them each equal to 0. 2x equals 1, and x equals 1/2. X equals 1. So my answers here are 1/2 and 1. Go to 13. This time 0 equals 2x plus 5 over x plus 5. So we split. I would multiply both sides by x plus 5. It's going to cancel out. And I get 0 equals 2x plus 5. 2x equals negative 5. And x equals negative 5/2. All right, that's the end of the notes for 2-3. Have a great day.